Okay, continuing on with our discussion of addition or subtraction of fractions, let's do another subtraction here. In this example, we'll call it C, we've got x over x plus 3 minus x over x squared minus 9. Well, now sometimes we don't have to multiply in an extra factor if we've already got something. So let's start with factoring first. I'll note that in my second fraction, I have x squared minus 9, which I know factors as x minus 3 times x plus 3. And I've got 3 minus x in my second fraction's numerator. Notice anything? Yeah, that x minus 3 and that 3 minus x are really the same thing, except one is the negative of the other. It's equivalent to writing x over x plus 3 minus negative 1 times x minus 3 divided by x minus 3 times x plus 3. And now you can see that there's definitely a factor that we can cancel from the numerator denominator. And we're left with x over x plus 3 plus 1 over x plus 3. So when we add these together, our reduced fraction will be x plus 1 divided by x plus 3. Right? The lesson here is that when you start adding and subtracting fractions, again, start with factoring if possible. All right. Now, sometimes it isn't always possible. Let's look at example D right here. In example D, I've got x over 2x plus 1 plus 5 over x minus 4 plus 1. Neither of the two denominators here look like they have anything equivalent. So we're going to have to get our common denominator just directly this time. So what is our least common denominator? Looks to be like it would be the quantity 2x plus 1 times the quantity x minus 4 times 1, right? Because this last fraction is really 1 over 1. All right, so what we're going to have to do is we're going to have to multiply in the missing piece from each of these fractions to get that common denominator. So what do? We've got x over 2x plus 1. Since the 2x plus 1 is already present, we're going to multiply in x minus 4 into the numerator and the denominator equally. Right? That balances our fraction. In our second fraction, we already have x minus 4. We have 5. But we're going to multiply in the missing piece of 2x plus 1 this time. Into the numerator denominator. Then finally, we look at our last fraction. It's 1 over 1. So we have to multiply in 2x plus 1 times x minus 4 into the numerator and the denominator equally. So 2x plus 1 times x minus 4, the same for both fractions. All right, so now what's going to happen? Well, we're going to have a bit of work ahead of us. But all of this will be over that common denominator. So I'm just going to go ahead and I'm going to make my common fraction right here. The denominator is 2x plus 1 times x minus 4. And it's okay to leave your fraction's denominator in factored form. Let me repeat that. Leave the denominator in factored form. But in the numerator, we are going to have to work this out. We're going to have to work out x times x minus 4. So I'm going to write that as x squared plus 4x. From the next numerator, I've got 2x plus 1 times 5. Well, if I distribute your 5, that's going to be 10x plus 5. But then I've got this last numerator over here to finish it out. plus 1. Well, that's 2x plus 1 times x minus 4. If we work that through, that is 2x squared. Minus 8x plus 1x gives us minus 7x minus 4. So let's combine what we can combine right here. I've got x squared and 2x squared. That gives me 3x squared here. Plus 4x plus 10x minus 7x. Well, 14 minus 7 is 7. So plus 7x. And we have plus 5 minus 4, so that gives me plus 1 is my constant term. And in my denominator, 2x plus 1 times x minus 4. And that's all we can do with this. This is now in completely simplified form. All right, one more to go.